All right, ladies and gentlemen, welcome to your video lesson for 11.3/4, the day one version of this. Today's class, we're going to learn all about elimination. And that is going to be our topic for the next two classes. Elimination is another way to solve a system of equations. We do this by eliminating a variable, and you'll find out why or how in just a minute. All right, so first we're going to tackle this warm-up. This is practicing substitution from last class. So let's see how this is done. Remember, our three steps in substitution involve, first step is pick an equation, solve for a variable, and solve for the easy one. Now, in number one, I don't have to do that because I already have y equals something, right? But if we look at number two, I would have to do that because I don't have x or y equals anything, so I have to pick an equation and solve for a variable. We'll talk about that when we get there. So for this one, I can move right to step two, and step two says substitute the equation that is solved for a variable in for the other, meaning I know that y equals some stuff, so I'm going to substitute that stuff in for y. So that's what step two looks like. I'm even going to label it step two. So here we go. I have 2x minus 3, and now I'm substituting x minus 1 in for y. So there's that. And then I just finished writing off this equation, which equals -1. Okay, so now I have to distribute. I got a couple signs that I got to pay attention to here. So this is a -3 that I will distribute onto each of these. So that'll give me 2x plus -3x, and then the negative times a negative here gives me +3 equals -1. And then continuing on, I have some like terms I got to combine. 2x minus 3x gives me -x plus 3 equals -1. And now I can start solving, which means I will subtract 3 from both sides. That'll leave me with -x is equal to -4. And x is not alone yet. I have not isolated the variable, so I have to get rid of this negative sign. How do I do that? By dividing by -1. Then I'll have x is equal to 4, and that is my answer for the value of x. Now, that is the end of step two. I'll start step 3 here, where I will substitute what I got for x into either one of these equations, the top one or the bottom one. It makes no difference. Just do the easy one. So from my eyes, this is the easiest equation to use, so that's what I will use. So you'll see me saying, all right, y is equal to, now instead of x, I'm going to write 4 minus 1. I'll get y is equal to 3. And I'm not done yet. I still have to write an ordered pair, which would be 4, 3. And don't lose sight of the fact that this answer represents the point where these two lines would intersect on the graph if we were to graph them. It's the answer to a system of equations. Okay, now this one, we talked about how this one would involve using step 1, where we have to pick an equation and solve for a variable, which means I have 4 options, right? I can solve for x or y in the top equation, or I can solve for x or y in the bottom equation. But there are usually an easiest variable to solve for, and that variable would be y in the top equation, because all I have to do is add 5x to the other side, done. So let's do that. If I were to add 5x to both sides, I would end up with y equals positive 5x minus 3. Okay, now I have the same kind of situation that I had here, where I knew y equals some stuff. So now I'm going to substitute that in for y right there. So that's step 1. Now I'll do step 2, where I'll have y is equal to, and I'll have, I'm sorry, not y is equal to. I have to start with the second equation, right? I'll have 3x minus 8. Now, instead of y, it'll be 5x minus 3 equals 24. All right, again, I have a negative to distribute here, so I'll have 3x, and I'll distribute 8, plus -8 times 5x is -40x. -8 times -3 is positive 24 equals 24. Okay, now for this one, I'll end up with a -37x when I combine like terms. And then plus 24 equals 24, which is kind of funny. Like you're thinking about, I have 24 over. Now watch what happens. I'll subtract 24 from both sides. and I'll have negative 37 is equal to 0, 37x rather. And well, negative 37 times what gives me 0? It's going to be 0, right? And again, if I divide by negative 37, which I'll do, I get x equals 0 anyways in the numerator. So that's all the stuff I have to do to find x in step 2. I'll use my value of x for step 3. Now that I know what x is, I'm going to substitute it into one of the other equations. I can also, I have 3 options now. I have one of the 2 original equations here or the third equation. I'm going to use the third equation because it already has y equals something, right? And so if y is equal to something, I can substitute 0 and get it really fast. So that's y equals 5 times 0 minus 3. And so y will be equal to negative 3. So my coordinate point will be 0, negative 3. And that's the point again where these 2 lines, if we were to graph them, would intersect. That's our answer. So that's a warm-up of substitution. Again, if you want to see these, you can go back and see them. All right. So we are not going to do the next one. In your notes, this is, I think, not worked out for you. But I have it worked out here because I'm going to prove a point, right? Just kind of observe what's going on. This is a system of equations, and I'm asking you to solve it using substitution. And as you can see, this one becomes potentially a kind of a nightmare because we have to do step 1, which isn't that big of a deal, but there is no easy variable to pick, meaning there is no variable that's by itself, but there's no way to get non-fraction answers when I do this. So think about it. If I were to solve for y, I'd have to divide everything by 3, which we do here, and we get 2/3, 2/3, which the fractions could be, you will get the right answer. It's just going to make it harder, right? Same thing if we solve for x. I will get 1 when I divide by 2 here, but I'll have 3/2 when I divide there. Same thing happens in the bottom equation for both x and y. Neither of those numbers are divisible by one another. So that potentially creates a whole lot of work for us. We got some fraction work here, and we have to do all of this just to get x equals 2, right? Which is just part of how substitution works. It's kind of a lengthy process. And then we don't change what we do, right? We still take that value, substitute it in for x like we're doing here, and then solve for y. And we actually do get a nice clean answer. Now, here's my selling point to you. For the elimination method that we are going to learn today, I can do all of this work for step 2 here, where we're finding x. I can do that in about 15 seconds, okay? I'm not going to do this, but I'm going to use the elimination method. So watch what I do. And it's going to kind of go over the top here, but that's no big deal. All right, so here's what I'm going to do. I'm going to actually take both of these equations, and because my y's, my x's, and equal signs are all lined up, I can do something called adding vertically. I can combine the like terms vertically for both these equations. And so I'm going to do that. I'm going to get rid of these circles here for a second. So I'm going to add them. Now watch what happens. Negative 3y and 3y just go away, right? They just get canceled out. That leaves me with, if I add these together, this is like 0. 5x plus 2x is plus 7x, which is really just 7x, right? And then 16 minus 2 is 14. Now, all I really got to do is divide by 7, and I get x equals 2. A whole lot faster than doing all of that. And I would do the same exact thing that we would do in substitution. Now that I know that x is equals 2, I will substitute that in here and finish it off, okay? But that is my sales pitch there for elimination. It'll save you time if that's the method you choose, okay? So let's get into some elimination here. I actually have some steps that I thought I stepped in here, but I guess I didn't. All right, that's okay. Essentially, elimination is this. We're adding the equations vertically to get a variable to cancel out, okay? So let's go ahead and actually complete that problem that we just had. Notice these 2 problems are exactly the same. We should get an answer of 2, negative 2, right? So when I add these equations vertically, 3y's cancel out. 2x plus 5x gives me 7x. And then I get my 14, like I said. Okay? And this is legit. You can do this. This is called elimination. We are eliminating the y variable. I'm going to divide by 7, and I'll get x is equal to 2. Okay, now what do? I do the same thing we did in all the other problems for substitution. I take my value of x and substitute it into one of these two equations, doesn't matter which one, and I'll find y. So in my eyes, I think the top equation is easier just because my y value isn't negative. So I'll use the top equation. So I have 3y plus 2, and now instead of x, I'm substituting into equals negative 2. This will give me 4, so I'll have 3y plus 4 equals negative 2. And now I got a two-step equation, right? What's happening to y? It's being multiplied by 3, and then I'm adding 4. So I will undo that by starting to subtract 4. That gives me 3y is equal to negative 6. I will now divide by 3. And I get y is equal to negative 2. And check it out. We get the same exact answer that we had before. We get an x value of 2 and a y value of negative 2. So our coordinate point is 2, negative 2. Okay, the next example is set up very nicely for you. So I would like you to pause the video, try this one on your own, and then come back and see how you did. Go. Hey, welcome back. Hopefully you did that, and let's see how you did. All right, I am going to start eliminating my variables. Now, look at this. I have negative 2y and positive 2y. That's the variable that's going to be eliminated. When I add vertically, I'll end up with 4x plus x is 5x, 12 plus 8 is 20. And now I got a two-step equation that I'll solve. I will divide both sides by 5 to undo the multiplication, and I'll get x is equal to 4. Once I get x is equal to 4, again, I can put it into any of the top two equations. I chose the bottom equation, so instead of x here, you see me substituting in the 4 right there. So I have 4 plus 2y equals 8. I have to start by subtracting 4 from both sides because I'm undoing what's happening to y. It's being multiplied by 2, adding 4. Last thing I said was add 4. I will subtract 4. So that gives me 4, and then I'll divide by 2 to finish it off, and I get the point. I get a y value, of 2, and I get the point 4, 2 as my coordinate point, where those two lines, if they were graphed, would intersect. All right, so let's take a look at example 3 here. There's a problem with it. The problem is it's a little bit different than all the others. Let's go back to 1 and 2 and observe some things. If I look at the variable that was canceled out in each of these, there's a common characteristic, and that was that they were the same absolute value, but opposite, right? So what I mean is I have a 3 and a negative 3, and I have a 2 and a negative 2, and both of those, when I add them, I get 0. They cancel out, right? And that's what we want when we do elimination. The problem is with this, I don't have that, right? 2 plus 2 is 4, and 6 plus negative y is 5y. That doesn't cancel out. And then the other one, we have the same problem, right? Still have a 2 plus 2, which is 4, and 3 plus 1 is 4. So nothing cancels out here. So what are we going to do? Here's the answer. What we do is we multiply an entire equation by negative 1. And it doesn't matter which one we do, top or bottom. I'll tell you what I do. I generally pick the top equation because when I do that, I can rewrite it right underneath, and then I can add it vertically. It's a little bit more efficient, a little bit more organized. Now, the thing is, the biggest mistake that most students will make is that they will only change the sign of the variable they're going to eliminate. You can't do that. You can't pick and choose what you want to change the sign for. You have to do everything. And this is a big distribution problem. It's not huge. It's 3, right? You have to distribute 3 times. So what I get is 2 times negative 1 is negative 2x. 6 times negative 1 is negative 6y. And then 6 times negative 6 is negative 6. Now I'll get some stuff to cancel out. We also have to pay attention to some signs here. The x's will now eliminate. I'll have negative y minus 6 more y's, which is negative 7y, equals negative 8 minus 6 more, negative 14. I'll divide by, and this is exactly what we want, right? We want a variable to eliminate, easy equation to solve, so we got it. Divide by negative 7 on both sides. I get y is equal to positive 2. Awesome. We're at the same exact point we were for all the other problems. All we got to do now is take this y, substitute it into either one of the equations, and we're good to go. I'm actually going to pick the bottom equation because I wouldn't have to multiply this. So it'll be 2x minus, and then here's my 2 going in. It's really like a -2 plus -2 equals -8. So I got 2y. Actually, I'm going to show a step here. I'm going to add 2 to both sides. That gives me 2x. I don't know why I said y. X. 2x, my bad. Equals -6. Now I'll divide by 2. I get x is equal to -3. So my coordinate point where these 2 lines intersect is -3, 2. Okay. So next problem I mentioned is set up the same way. You're going to have to pick an equation and multiply by a negative. Go ahead and try it. Pause the video, do it, come back, see how you did. All right. Hopefully you did that. I rewrote both equations. I showed you that I'm going to multiply the top one by -1, and then I rewrote that right underneath it. So now I will get my y's to cancel out, and now I can add vertically. X minus 3x is -2x. -1 minus 5 more is -6. I'm going to divide both sides by -2. X is then going to be equal to a +3. And again, now that I know that x is equal to +3, I can substitute it in any of the equations that I had. I could even do the manipulated one, right? The one I multiplied by -1. So I chose the bottom equation here because x was all by itself, and that made it an easy substitution. So when I did that, substituted in, I subtracted 3 from both sides here, left me with 2y equals -4. Then I divided both sides by 2, and I got y is equal to 2. So I get the point 3, 2. Again, that's where these 2 lines will intersect when you graph them. All right, now, there are special cases, right? Remember last class we talked about how there are 3 types of answers when we talk about systems of equations. So those answers graphically are, remember, I'm going to get a different colored pen here. They could, traditionally, like most of our answers that we've gotten so far, the 2 lines are going to intersect and we get an XY coordinate point out, right? Or the 2 lines are parallel. Let that go away. The 2 lines are parallel and then we get no solution. Or the 2 lines are the same line and they're right on top of each other. That's my illustration of 2 lines on top of each other. And they intersect infinitely many times. So we say infinitely many solutions. So the question is, well, what does that look like? How do I determine, we know what this is, right? We get an XY coordinate point out, but how do we know what these 2 are when we're doing the elimination method? So let's check it out. I'm gonna go ahead and clear this ink. And so, using elimination, if I look at this, I kind of have that same problem that I had before, right? The variables aren't going to cancel out right now. So I'm going to multiply one of the equations by -1. I'm going to do the top. When I do that, I will end up with -4x plus y equals -3. Now I'm just going to check my work because what's going to happen here is going to be weird. -1 times 4x is -4x. -1 times -y is +y. -1 times 3 is -3. Okay, now I'm going to add vertically. 4x minus 4x is 0. -y plus y is 0. And that's going to be equal to a -5. So really I have 0 is equal to -5. Okay, now you got to think back to what we did last class. When this happened, when all the variables got wiped out, they were eliminated, we had to evaluate if this was true or not. Clearly this is false, right? And what we said last time is going to be true this time. If I have a false statement, when all the variables drop out, we say that there is no solution. So these 2 lines are parallel. They will never intersect. There is no intersection point. Now I'll do the same thing for this one. This one's kind of nice because it is set up to eliminate right away. So I will get my x variable to eliminate. X minus x is gone. And then -6y plus 6y, it also gives me 0. And 7 minus 7 also gives me 0. I get the same thing, right? All the variables cancel out. And so I have to evaluate whether or not this is true or false. Well, this is clearly 0 equals 0, so we're going to say that this is true. And again, same thing as last class. If we get a true statement, What we say is that we have infinitely many solutions. All right. So that is our class for today. Hopefully this video helped you guys out. Don't forget about your independent practice. You're only doing the day one stuff, which is on page 51 to 53 in your packet. It is out of the textbook 11.3. Don't forget to do the accuracy check and upload a picture of your work. I hope this helped. Adios.